Welcome back to the OpenVINO channel. Okay, my inference looks good. I can build a full pipeline of video analytic or other AI-based application. Where is the money? How do I actually create a commercial application out of it? Probably not easy. Well, it is easier than you think. OpenVINO, as you all already know, is not just an inference API. With OpenVINO, you're getting all the tools you need, resources, samples, models, and more. And at the end of this flow, when you got your algorithms and model ready, we have easy ways to deploy your application. Your first option is to integrate the inference engine code into your application. Use one of the sample codes supplied with OpenVINO for reference. VA serving, video analytics serving, allow you to build not only an inference server, but a full DL streamer-based pipeline as a service. We explain and demonstrate it in another video. Or you could use Azure to build an OpenVINO model server. You can find all the instructions online. And the last option is to use the OpenVINO Model Server. OpenVINO Model Server is a scalable, high-performance solution for serving machine learning models. That QR code will lead you to the full documentation. The model server is basically taking the inference engine runtime and packs it into a network service. You can choose a network protocol to be gRPC or REST. OpenVINO code is highly portable, as you already know, so the actual serving inference could be done on multiple devices. If my server has a Core or Xeon CPU, an integrated or discrete GPU from Intel, or even a VPU, I can use almost the same code for all. So we basically have here a package of the inference engine code and your model. And of course, it could be multiple models, not only one. And we are adding a network communication layer on top. And it can all be run in a Docker container. You can deploy it on Kubernetes cluster or any local machine you have. And potentially serve any number of clients, which can now be very simple low-power devices as the inference is done by the server. This is a high-level architecture of the server. You can find many more details in the documentation page and on GitHub. I'd like to show you how it works. I'll be following the quick start guide on this link to implement a face detection model server. It is simple to follow and will take you minutes. Let's clean up first and make sure I have no images or containers in my system. Do I have images? Yes, one. Used by any container? Yes, I have two of them. Let's remove this one and the other one. Oops, it is running, so let's stop it first. And now remove it. And I have no containers. Let's remove the images and I'm all set. And let's pull the model server Docker and I'm ready to go. First, I download the face detection model. Here are the IR files and I'd like to place them in the right directory structure. This is my model 1. I can have many of them and you can see how they are arranged under model/1. This is all. Now I can run the server. I'm using the model server Docker. I'm using the face detection model, and important to ask for auto shape as the input images from the client might arrive in different sizes. And the server is running. Moving to the client. I'll run the client on the same machine, but it could be any other machine. I'm downloading all the client utilities and the face detection script. Let's look at the face detection script. Here, we're taking all the input images and we're sending an inference request. You can see that we use a TensorFlow Serving API for the specific model we want, and now we're taking the results. You can see that gRPC request, and here is the output. Basically, the detected faces bounding boxes, which I draw over the original image. Let's try it out. I'm downloading some sample images. They are in the images directory. I've actually placed many more images there, not only this one. And I install the client requirements, prepare a directory for the results, and I'm all set. Let's run the client. I'm sending a request to the server to take the images from the images directory and place the results in the results directory. I've opened here a top view on the CPU. Sending the request, you can see that the CPU utilization is up and immediately down. I get the full report, but let's look at the results. You can see that all the faces are detected and the bounding box is drawn on the images. This is pretty cool. So take your models and pack them into a model server. Take your application code and create a client that can use the server for inference. Don't forget to subscribe to the channel and tell us how it works. Thank you.